This is a collection of relatively small introns. Later on, I'll show you a collection of larger introns. The features that you can see here are the following. There's a red square that indicates where the beginning and end of the sequence are located. The stems, the loops, can be turned off with this switch and turned back on again, of course. And then the big stems are the green ones in green, and then the small stems are the ones in white. Okay. The small stems are between 2 and 7 here, and the big stems are between 8 and 19. And in these small introns, there are no dicer stems, by and large. So there's no red set of stems. And at any point, you can put on a graphic that tells you the length of the stems. The numbers are rather small, but of course you can always pick a center and then zoom up, and you can see the number relatively more easily then. The stem length, loop size, stem labels, it's more technical, and stem level. Stem level is interesting because the end of the sequence has the highest number, and then the loops that go from it are lower in number. So for example, this branch here has as a secondary loop number 2, and then a leaf number 1. So it goes from 12 to 11 to 10 to 9 to 8 to 7 to 6 to 5 to 4 to 3 to 1. So you get a very nice sense from this loop level, stem level indicator of how the structure is formed. So I'm going to run through a number of different images. Some of them are, oh, I see. This is the pruning. Now, what pruning does, it takes all of the leaves and the branches and recursively prunes away. So in the first pruning, you would eliminate this leaf here because there's nothing exiting from it, and you'd eliminate this, and you eliminate that, and this, and this, and this. But once you've eliminated both of these, well, then this thing becomes, in effect, a leaf, and you can eliminate that. And so the algorithm for pruning simply says that we'll eliminate leaves until we get a repeat, in which case we know we're down to the basal structure. And then because the leaves and branches have been eliminated, we now know how to draw it a bit better. So this is the prune of the structure we saw just a moment ago. And I guess we'll have pairs of these things here. So this is, again, a relatively small structure. You can see it's a beginning point. And but what's characteristic here, of course, is that you've got one region here and one region here that are relatively large. And then the prune of this shows that rather nicely. Okay. Now, eventually, when I figure out how to do it, I'll put back the leaves and branches on this diagram. And so the structures will be spread out in space more appropriately, so there'll be no spatial conflict. But I haven't figured out how to do that yet, so I'm still one of the things to do. Here's another small structure. Again, of course, you can always turn off the loops and look at the stem structure. Rather nice. Here's the prune of this structure we just saw. Here's, again, a relatively small intron. And now this is its prune. I'm just going through these one of them. Now here's something larger. Again, this doesn't have any of the dicer stems, so these are all stems that are less than 19 bases. But this structure is, well, it's fairly well resolved in space, but it's a little bit of conflict here. If we go to the prune structure, you see that it's much clearer what the overall structure of the intron is. So the pruning actually is a rather neat property. Shows the topology, the macro topology of a sequence in comparison to the microstructure. That was the full. This is the prune. Here's another example, getting larger and larger. Again, this is the full structure, and this is the prune structure. Once more, this is the full structure, and you can play with these things, and all these examples are available for you to play with. And this is its prune. So this is a relatively simple prune structure. Stop now.